Okay, we are live. Good morning. Plan for today. Oops, this is the wrong Docker. We're pretty close to having like a stable pre-alpha. I'm thinking we get our sweeps working today. Whoops. Seriously, Docker? Hey, Pepe. There are a couple things I want to look up real quick, you know? Mm-hmm. Mm. Most recent run. One B beta lead. Okay. Oh, cool. This thing just runs. Hey, user. Hit N. Page up, page down. Metrics, grids, columns. Systems metrics. Interesting. Oh, okay, that's not bad. I mean, you don't really have any way to do steps or anything. This is like a nice quick thing, I guess, for the latest run. Filter, clear. That's not bad. It's not great. That's something. Can you have multiple runs on this thing? Or is it single run? Oh, it's single run. I mean, we were gonna have Constellation anyways for multi-run, right? Maybe that's what we should get working. The only problem with Constellation, right, is it's a visual interface. No, I think we should still get Constellation working. Then we'll have like the full end-to-end of it, which will be nice. And then we'll honestly though, this 1B elite thing is for just like having a couple graphs of the latest run is pretty solid. And the fact it works offline is very, very nice. Yeah, I'd say that's very, very nice. Cool that they have it. Oh, but yeah, let me get one other thing real quick. Yeah, let's see if we can just really crank on the end-to-end today. So first of all, start time. Yeah, I need start time first. That's fine. This is still very good. Now let's see, does this exit cleanly or not? Does not exit cleanly, so we gotta fix that. So what we're gonna do is we're gonna make a close method. I'm gonna do like this. Close. Train. We can just do void close. This does not need a GIL release. Why is it doing this? Wait. Yeah, we don't need these brackets. And then we have PufferLib close. PufferLib. This is backend. That does not seem correct to me. It should not have a dot close. Not used. Where did I do this? PufferLib is vec. So create environments returns vec. Hey, how's it going? Going pretty well. Just started. We're gonna try to get local hyperparam sweeps running super fast right now. Sample logits. Cool. Static vec. Oh yeah, we don't even have to do where's this? Do we not have static vec? And binding. And binding.h. Oh, right, we don't have vectors anymore. Perfect. So now what we just have to do is we just add static vec void static vec close. Just do static vec close. This is fine. We can, oops, do we free the environment? No, we do not free env. We free envs. And then everything else also has to get freed. I actually need to see, how do you free a CUDA host, Alec? I don't know how you do this. CUDA free host. CUDA free host and CUDA free. Fine. Oops. Stupid button. Okay, so what is this? Buffer states. Well, wait, we have to stop all the threads, don't we? And these are while. Funny. I forget it. What's the sig? Is it like p kill? No. P thread cancel. No, still need to join. Right, yeah, okay, fine. Fine, we'll try it this way. Yeah, see, this is just not gonna work, is the problem. I think the answer to this is, like, it's gonna have to get redesigned a little bit, right? Let's not use Opus. Don't be tempted here. We have to do this correctly. Do we have atomics in here? No, we do not have atomics in here, so we can't do this. We can put it in static threading. Yeah. Running SPS? No. We have a lot of SPS. Now I'm going to try to make it gracefully shut down and, like, make sure we're not leaking stuff so that we can get sweeps running. I'd really like to have, if we can see 10 experiments of breakout running per minute, that'd be awesome. I might even be able to test this with Pong and get, like, 20, 30 experiments per minute. Ah. Effective each hyper. Yes, so that's constellation. Um, the goal of that visualizer. It's the same thing. That's still going into the release. What's the level of perf on this loop? Okay. I guess here's what we can do. This is what we can do so that we can make this one while true. And then we can do See, the problem is this break. This break is not good. Wait, we can just return. I'm dumb. Why? Don't be stupid. Good luck, PhD I love your content. Thank you. Yeah, it's a lot of just like low-level fiddling, as it turns out, because most of RL is just bottlenecked by systems, not anything else. There is actual algorithmic work to be done, but I mean, it's way, way easier when stuff is fast, and we're mostly bottlenecked by stuff just being slow. How's this? This should be good, right? I'll have to see if they fight over this resource. Okay. We have to signal all the threads to stop. Yes. So then we join. Okay, so now we free the ends. We free buffer state threads, threading, buffer end start and count, so everything gets freed here. Then we need the CUDA freeze. Oh, the streams. Yeah, we need to. How do we close streams? Vec streams. How does this work? Oh no, wait, PyTorch is responsible for this. We can ignore the streams, I think. Free host. Free vec streams. And now what about vec streams? PufferL torch streams of buff. Oh, so these don't get used. Wait, no, they do get used. Streams of I. I think you do free it. I think you do free it. It's a little weird because we have like this mixed C++ jank. But I think that this end close should be good. And then all we need to do close. This is probably going to be one of the places where I do need to ask Claude because this is not just freaking C++ hell here, right? Weights for sure. No, because weights are just allocated with zeros. Does it just go out of scope? I mean, we can try this first, right? Definitely want the startup and teardown time to be very fast. Oh, come on. Static vec log. I just do this. Okay. We didn't lose any perf, it looks like. Good. Export it. Where's our top level function? Rollouts. Hey, Liberty. What the heck? Where did I put close? Close. No matching function. Do I need to put, that's weird. Let me just try renaming it in case it's conflicting. Hello, welcome. That looks good, right? It's a lot of eval steps. What did Kyung have? I see. Morning, Jess. We uh we got this thing to close cleanly, it seems. That's nice. There's your 7-second train. And that's something. What to close? The environments to close cleanly. We're trying to get stuff cleaned up so we can run sweeps. Many agents who are good at something work together. Well, the LLM version of it is completely fucking stupid. And you can have specialist agents for stuff that makes more sense in RL, frankly. But then the whole work together part, it really depends on the problem. It's not something that you just like throw out as a general concept and immediately have transform everything or whatever. Multi GPU. Let's get single GPU sweeps first. All right. I'm trying to think how I want to go about this. I think we can just try. Let's try without, let's see, sweep. And get Constellation to run, maybe. That'd be really cool. That we can totally set up local, right? Let's do that. Don't need to require 1B. Oops, that's C and Python in one. What is wrong with me? Max cost. Okay. It's a sweep. Sing hyper. Train at num at mini batches. Which is no longer a hyper. Gone. But this should be replay ratio. So here's something cool that we haven't thought about, guys. I actually think it's possible that we solve breakout substantially faster than 7 seconds now. And the reason is we have configs that used to not be computationally efficient that are computationally efficient now. So let me explain what I mean by that, right? It used to be that if you ran at batch size 2048, for instance, it's the exact same speed as running at batch size 1024 because you didn't have it optimized, right? So basically everything's dominated by overhead, which means you'd always just run big batch size. And this is one of the cheats that I had in Puffers. People said, well, okay, we're just going to run everything at big batch size then until we make stuff faster. Now we've made stuff faster, so you actually can get benefit from going smaller. It took us wading through 9 levels of coup de hell, but we've done it. So hopefully that should get us some interesting new results, qualitatively interesting new results. Just go away. Nice. Mini batch size must be greater than or equal to horizon 32 times total agents, which it is. Less than equal. That PufferLib 83. Why do we have this few total agents? We'll just set some reasonable bounds. Interesting. So probably here we have like some policy sweep stuff. So what do we have? Policy gets hidden size num layers and expansion factor. Hello. Whoops. Okay. Well, that's interesting. It managed to go find a very, very slow config. Max cost can go down to 30 now because everything's so fast. No need to wait longer than 30 seconds for a run something as simple as breakout. It was the old soda. Okay. So now this should time out after 30 seconds, right? So this trained the full minute and 4 seconds, which is not ideal. And then we error on this, which is total agents. Okay, so there should not be a 4096 in here unless it's the mini batch. Total agents, no buffers. Oh, it is the mini batch size of 4096. Does that make sense? The horizon is 32. Yeah, it looks like the input size got messed up, right? Yeah, the input size is messed up here. Hang on, we have... Where's hidden size? Horizon? Okay, it's not in here. Hidden size here. No 128 anywhere here. Well, I see it on the default here for the hidden size of Mingrew. Is it not getting passed, I wonder? No, I see hidden size here. Hyper's hidden size. I guess we can probably see it from here. And where is it? There. You just need to get all the hyper combinations nice and stable so we can sweep. I mean, it should realistically, it should be very, very fast. What's this max cost? This is in train. Look at that. Imagine we end up with a 3-second breakout solve. How will we celebrate the 5K Puffer star party? Y'all gotta start Puffer. So we get to 5K. I don't know. I could come up with something cool to do. 5K is a really awesome milestone. There's all sorts of cool stuff I could do, to be honest. It's just like, there is so much work to be left on Puffer 4. And I know that I have a couple contracts that we're starting pretty soon. I've kind of been able to do more work on this than I was going to be able to because both of those contracts got delayed a couple weeks. But like when I start those, I'm going to have even less time to be on the core dev for a bit. So I've just wanted to really get something as close to stable as possible before I start on all that stuff. I mean, it's so much work. It's just so much work. I do have a couple things I want to do though with Puffer the next time that things are in like a good spot and we want some new environments or we want some new stuff to look at. I got a couple cool ideas. Oh, it's in the create error. Wait, the create errors. Really? Interesting. Hmm. It errors when we pass different hidden size? Really? Oh, it's the expansion factor. I see it. Yeah, I see it. I think we're just not gonna do expansion factor for now, right? Is there any benefit to doing that? Here. 100% this. 1.6 mil per mnet, training 3 mil SPS. Oh yeah, we gotta fix the SPS calc though. It's a little weird with the replay ratio being able to go under 1. Well, sweeps look like they run. Dude, that's pretty cool. Yeah. This just runs. Cool. We also have this whole frame skip thingy. Hmm. I think let's commit this. Well, where's the constellation build? You need CJSON as well. That's no big deal though. Okay, let's do this. I'm gonna go grab myself a mug of tea. Let me commit this, and we're going to get set up on my local. We're gonna get constellation set up. What? Get PufferLib? Yeah, get puff. If you haven't seen Constellation before, it will be very, very cool. It's essentially, it's this pure C, really snazzy rendered UI for hyperparam sweeps. I spent a little bit of extra time making it look pretty. Uh, and I want to see if we can get data from Puffer 4 into Constellation, because I think it's going to be really sweet. Like, let's say that we set a 10-second timeout or a 5-second timeout on breakout experiments, or on Pong experiments, rather. Like, that means we can collect 10 to 20 experiments per minute of Pong. So that's really sweet. I gotta use the restroom real quick. I gotta grab myself a mug of tea, and then we are going to go and see if we can get that set up. I'll be right back. Okay. Okay. Now I will show off the cool thing. I shall show you the cool thing. Uh-oh. Huh? Constellation. We need CJSON. Oops. CJSON dot C. What's the license on this? Do whatever you want. Very nice. And Ray GUI. We need to get these included as well. Install. Single file header only. Ray GUI.c. Source. Is there a .c? Hey, there's no .c, right? Source. Yeah, it's just the .h. Yeah, we're definitely gonna need Ray camera. Where's this thing? I don't know why this isn't in there. I didn't like, whoops. I didn't bother, like, setting all the build stuff up for this. There we go. Oh. Lomp. Eh. Lomp. Why does it have brew? Why does it have brew by default? Fake operating system. Okay, now hopefully we have Constellation. Let's see. Yes. No? And oh no, you know what? I know what this is. I know what this is. This is fine. This is why you should write your stuff header only. This is why you should write your stuff header only. Because otherwise people have to remember to do this crap. Web, blah, blah, blah. see JSON like this, right? Multiple definitions of huh. What the heck? And that's super annoying. Oh, because you're dumb. This is why. It's just because you're dumb. It's that easy. There you go. And then you have to give it a file, right? PufferLib Ocean Constellation default.json. Okay. Did we make a JSON file here? Or do I have that JSON file somewhere? I don't know if I have that JSON file somewhere. Let's go check. We can get our data loaded in. Close, logger.close here, right? Self.path. PufferL logger.close, right? Right here. Return all logs. Okay. And then you have logger close and model path. Model path is PufferL close, which does not return the correct path at the moment. So we need to fix that. To explain what's going on here, let me do that briefly. So the idea of Constellation, it's an aggregate run viewer, right? So you grab a whole bunch of runs, you post-process them, you load them into Constellation, and it gives you a bunch of stats and visuals. Technically, I suppose you could use it sort of for single runs as well if you really wanted to. I could experiment with that. Yeah, I could experiment with that. But regardless, we just have to figure out why stuff is not saving. Go check this one. Okay, cool. So we have path, path. Five. Okay, so this doesn't have the model in it for some reason. So I think what we should do is I should put this breakpoint up here. We should see why it's not saving. Mindia. Hello, Chief Puffing Officer. Yeah. This is amusing. That's super cool. Oh, that looks really awesome. Yeah. Yeah. Ray sounds really awesome. Number of samples used for training. Why is there no documentation of example commands to get started? Because there's an entire website for you, my guy. There is an entire website for you right here. It's linked on the README. You have an entire website with docs. Here are all the cheat commands, right? All the cheat sheet commands. Here are a whole bunch of examples for you. Here's a little bit about the design of the library, and here's a detailed tutorial on how to write your own environment. Now let me see if this is on me. All our documentation is hosted at puffer.ai. I think that's pretty clear, right? What is the ratio of your portrait video? There's no specific ratio. It's a standard video format, but then it's clipped, right? Like I just clip the video to fit myself on the screen. Like I can do this, right? I can also do like this, you know? I considered having our docs be like mirrored to the main page, but that's really annoying because then I have to write our docs as a .md, or I have to write our docs as a .md, and our docs are not in Markdown. Our docs are HTML. I don't know why GitHub doesn't just render an HTML for your docs file. It would be so much easier. I remember that one time they had that injection bug where you could basically theme your GitHub homepage however you wanted. Man, that was so cool. Something something Microsoft security. Concerning amount of coffee. This is tea with 1 tea bag. It's just weak tea. I actually don't really have that much caffeine these days. There were several years of my life where it was like 4 energy drinks a day. I remember in high school there would be days where I'd been up for the last like 30 hours, where I would sit down for lunch unironically with 6 to 8 shots of espresso just to get through the day. I don't do that crap anymore. I sleep, and I don't have that much coffee or that much coffee anymore. I have some. Okay. We're just not saving our model, are we? Ah. I wonder if we can do this. PufferLib policy min grew. Health NRL, yeah. Oh, I'm in good shape now. I did a couple weeks ago. I did a 20-minute 3 mile. Uh, a little earlier, couple 2-3 months ago, I got up to a four-plate dead. I got back up to a four-plate deadlift, only weighing 172 pounds or so myself. Exercise is very important. I'm doing a little bit less exercise now than I normally do. Um, but I mean, I'm still training hard 3 times a week for like 2 hours. But 6 hours of exercise a week. Why does this not export state dict? Actually, this is a Claude thing. This is 100% a Claude thing. My guy, are you stupid? Of course it's stupid. It's a neural net module. Actually, I'm sure it has these. What the hell's wrong with this? Well, it has dot parameters. No built-in state dict. Okay, we're gonna not listen to Claude. It's honestly like, yeah. Hey, if every time I go to use it I see it's stupid, then it's like, that's good, right? Can I not just do this dict of you can just do dict. Named. Try this. Expected f to be a string? Really? How do you save port save sequence? Stupid torch. That's super annoying. Hello, SPY. I mean, you're the one who keeps bringing up feet in my stream. So I don't know what that says. Yeah, this is bullshit here. This is like giga bullshit. I would like to be able to load models. Safe tensors to make sharing models viable. Does that work cross-compatible with... So I hate adding dependencies. Does it work cross-compatible with libtorch and Torch's Python API? Because this is like a pure meta fuck up. The fact that their save function does not work between C++ and Python. Check to make sure. I mean, I don't know if it's a make sure. I doubt it is. Like, this is just Torch purely screwing up. I think what I'm going to probably do is I'm going to finish Puffer 4 in Q1. We're going to have a few months worth of client work plus research on Puffer 5, which is like pure algorithmic. And then probably by Puffer 6, I think it's going to be time to delete PyTorch. We'll see. I'd prefer not to have to, though. Like, oh, we'll see how TinyGrad does, but I don't see TinyGrad replacing what I'm doing unless they go with a unless they get a lower level interface. It's the wrong level of abstraction. TinyGrad is very, very good, and I think it's probably the best for pure Python, but you need lower level. What's wrong with this? Oh, you're just doing it in the wrong order, you dummy. Cannot pickle this. Cool. Alright, you can do this. Constellation.py. Okay, so this is the shitty version, right? Compile puffer. Yeah, this is Constellation. We do not have cost in here. That is bad. Oops. You have to have log cost. We'll do log cost. It will test. I think that I just got it to save at least the dictionary weights. I think I can probably just write a few lines of code and not add the dependency. I'm really sick of PyTorch though. I'm sick of PyBind, I'm sick of PyTorch, I'm sick of Python, I'm sick of C++. It's really incredible to me how many of the vast majority of the like innovations in abstraction, like how to like higher level stuff are just lies in the modern era. There are two ways to make things simple, right? Is to work very hard or to lie. And I mean, most of the stuff that I'm seeing in Torch and whatnot, it's you just lie. Because you're losing all this performance, you're losing all this flexibility. Sometimes you're even making stuff more complicated than doing it just the fast, simple way. It's really sad. What's wrong with this? Python with Vim? What do you mean Python with Vim? There's a tiny amount of Python in this project because researchers want Python binds. It's mostly C, C++, CUDA. I mean, I don't blame them. It's just like, screw this shit, I'm out, is what that is. Okay, why do we not have cost in our data? In the sense of security, you shouldn't be loading random ass models. What are you making? I developed PufferLib. This is the highest performance reinforcement learning library out there. You can take a look at some of our environments. We do algorithms research, we do new infrastructure, low-level engineering, environment and simulation creation. It's all open source. And I just stream all of my development on this. I'm a researcher. I've been doing this type of stuff for a decade. I run a small private research lab around this. But since all our core stuff is open source, I get to stream it. And it's fun. I know when I started this, I kind of figured, well, there aren't really many watch cutting edge research being done live streams. So that sounds like a cool thing to do. Where's the JSON file? Self.path. Args of datadir. Ah, okay. Try this. That's cool. Yeah. You're using Linux? Everybody who's doing serious scientific computing is using Linux. It's just, there's no way around that. You'll just waste a lot of time on dumb things otherwise. Okay, so we have some outdated stuff here. I think all the rest of these are fine. This one no longer exists. This is replay ratio. And then this is total agents. BPT horizon is now just horizon. Okay, you can't tsne one sample. Let's just generate ourselves a few runs. Do code in C++? When I have to. It's a terrible language. Unfortunately, we have a lot of it in here because of the Torch APIs in C++. I don't even want to look at how much stuff we have in here. Yeah. I don't know. We probably have 4,000 or 5,000 lines worth of C++ at the moment. I wish we did not have. We have like 50,000 lines of C. C is so much nicer. I think eventually we will strip out all of the C++ and just replace it with nice simple C. We'll probably keep the Python bindings, but we'll have very, very thin Python bindings. C and Python is a very good stack. Love C, yeah. I'm just happy when I get to be writing C. Like, things are just simple and work. Somehow that says it's running at 20 million SPS. I don't trust that, but cool. Helix? What's Helix? Oh, the editor? I don't really need an editor. Yeah, Rust. Or terminal. Oh, okay, at least it's an app. I mean, like, this looks fine, but do I really have any need for this? I probably should take a little bit of time at some point to get basic. I probably should take a little bit of time to have basic stuff like this, either in my Vim config or whatever, considering that um, I've decided that most of the AI crap is just not good. It would be better to get more out of my existing tools. It's a little irritating because it's like, on one hand, a lot of the editor tools, it's built to like let you manage large redundant code bases, but you shouldn't have large redundant code bases. Of course, with this version of Puffer, we kind of now have a unavoidably large and redundant code base because of Torch. So, yeah. Built-in LSP is nice. So the one thing that I absolutely need, at least until it stops being supported, there's a plugin for SuperMaven for this. So SuperMaven is really, really stupid AI tab complete. So if I like start typing, it's really stupid AI tab complete, but the model just runs really fast. That's pretty much all I need, is I need like some really stupid model that runs really fast for tab complete. Like definitely sub 250 ms, ideally faster. I'm a little concerned with this sweep that we're not finding good hypers. That's kind of odd. Well, let's see if I can run cache data. Perplexity must be less than num samples, which is 1. Why is num samples 1? Because if you get cut off, you don't log. Great. Before close, we should do log cost. And then do this maybe. It's a little odd. Is that AI model free? It's no longer supported, unfortunately. So it was from SuperMaven, and then Cursor bought SuperMaven, and then Cursor was going to shut down the old SuperMaven stuff, and then all of the users bitched a whole bunch. So they said, "All right, you know what? We'll leave it on." So we still have the model for now. New here, what are you building? I developed Puffer. Puffer is the highest performance RL library. You can check out a lot of these demos on puffer.ai. We have all sorts of agents that run in your browser. Think like tiny superhuman models for specific tasks that are trained on decades or millennia worth of simulated game data, or not just games. We've got drones, we've got driving, pretty much any types of sims. And I stream all of my research. I don't know why this is like this. Write logs. Oh, I see. So then this should be fine if I just do log cost, should it not? Very silly. Use Raylib for the sims. Raylib is simply for rendering the simulations. It's not for the actual logic for the most part. I mean, sometimes we use some of their math functions for convenience, but their math functions are like a few lines if you want to implement them. Ooh, hey Finn, we've put some more details about our unis. Yeah, so this is, you got to keep reminding me about that because otherwise I will forget. But I did agree to do that, and I will prepare a talk for it. Let me go update Discord so I can go see what that is. Finn is the one of the two people who made the drone environment, by the way, that I just showed on the website. Probably the best standalone environment PR we've gotten. #21st. Time slots to the time zones. What is the 21st? 21st is a Saturday. I will be free all day on a Saturday. I am on Eastern time. Oh, geez. This is going to be UK, isn't it? UK, TST. Oh, that's not bad. GMT is UK, right? Or am I stupid? Yes. Okay, so let's say that I'm free from 9 a.m. I'll write this down. 5 p.m. is noon EST. Let's say trying to slot me at 9 noon. Oh, currently 4 o'clock is fine. Okay. Works. There you go. There you go. There's your reply. Yeah. Leaving to code. Hope you enjoy coding. I normally do. I'd really like to be fighting with Torch way less. But I normally do enjoy my work. I think it's just this type of stuff burns me out very, very quickly. Well, not this. This is easy ass Python. Most of my stream is just fighting all sorts of low-level infra with Torch in their C++ code. Perplexity must be less than n samples. Okay, well, we're gonna just go look at what we have, because presumably this is just like bad data. Cute tsne. Do we even need tsne? Cache sweep load. Okay. That's fine, right? Now what we need to do is SCP this. Let's see if we can just go from here, right? Oh, nothing. Suarez puffer tank. Okay. Default JSON. JSON like this. Tsne1 not found in env. Okay. Yeah, that's a little bit annoying, isn't it? So we need to just fake some data, I guess, until we until our Tsne works. Zero times size. Yeah. We can try this. Don't need Claude. You know, I used Claude for a few weeks. It's just bad. It's really bad. Like, I don't feel too stupid about it because the codebase I was using it on was unavoidably shit, right? Like, I inherited all the garbage from Torch, and as a result, a lot of the code is very redundant. I definitely overused it a bit even then, though, and like, the model is very, very dumb. I still think it's okay to use it for very deterministic refactor ops. I think that there's a place for it, but this whole zeitgeist around it is completely unjustified. What's this supposed to be? Dot to list to row plus size. Isn't this supposed to be constellation? So 312. Compute ticks. Ah, I see. Let's just give it let's just give it this. Object of type ND array is not JSON. Okay, to list. How do we still have this inf? Looks fine to me. Did I just mess up the... Hang on. Cache data. Right? This is just not saving correctly. There we go. So now we copy it. Now we SCP. And now we do... Oh, no. Now we copy it to the right directory. How do we still get an error? Interesting. Well, I'm gonna use the restroom real quick. I'm gonna get a refill on my tea. And we'll figure this out. I mean, the goal for today is basically to get training data from sweeps loaded into Constellation and start iterating on the actual experiment loop, you know? We start to get the full end-to-end going. Don't use it to implement PPO. Holy. Yeah, that will be a total disaster. I actually wouldn't be surprised if it makes something work, but like, you will get better code. Just go copy paste CleanRL. Like, it's trained on CleanRL. You'll do better just by copy pasting CleanRL. Right? I'll be right back. Welcome to Florida. I just go look out the window and there's just a bobcat there looking at me like, "Hey, how's it going?" Plot width. Wait, why is this? Huh? That doesn't make sense, does it? The heck? Huh? What'd I do? Okay, so the X min and maxes are bad. Right. Yeah, it's not logging we'll fix that. And how are we still gonna segfault on this, huh? I ran cache, I copied this. Like, how are we still gonna segfault? Yeah, why are the mins and maxes like this? They shouldn't be. You know what? I bet it's caching stupid. I bet it's caching stupid. Cache. C cache. I bet it's this. Really? Still? Let's look at compute ticks. Tick label size. Becomes 312. Why is tick label size 0? Is it the TTF? Oh, it's the frickin' TTF, isn't it? Wait, resources shared. You're dumb. Good. There we go. There we go. Cost, environment slash score. I don't see it on here is the problem. That's weird. Well, this does not look anywhere near as snazzy as it looks when you have a bunch of data loaded incorrectly, believe you me. Doesn't show up here. That's very weird. Does it? No. No, it's nowhere. Well. Check Discord. Let me see. Hey, Spencer, we're hooking up Constellation, or attempting to. So we're getting close to having some sort of end-to-end. Ooh. Huh. That's a good model. I don't know why. It's not log linear, right? It actually does level out. Unsweep because speed, yeah. Well, we got some chess. I mean, that's a very good starting point for this, I would say. It doesn't seem log linear in compute, though, right? Like, towards the end, that's actually leveling out fully. That's a good model, though. Yeah. Okay, I mean, solid progress there. Did you say something, by the way, that you had the drive ends? One map perfectly, okay. There's definitely some jank in 4.0 we're gonna have to fix before we can get everything onto it. It goes to 0. Yeah, I don't know if it's the kernels or if it's bfloat. Um, there are definitely some instabilities, I will say. I'm trying to see if we can get sweeps working. Like, if we can get the whole end-to-end sweep plus constellation thing working on even just on breakout, then my hope is that we can sort of crowdsource a little bit. You know, if I can make the setup easy, we can have some of our contributors fiddle with some of the individual environments. I think that there's also likely to just be some numerical stuff that needs to be improved in both the kernels and bfloat. It's very cool, though. It is very cool. Just because of hypers, yeah. Those are individual experiments that you're seeing on Pong. That's kind of nutty. And then we get the downsample bug. Cool. Because it didn't get any signal. Okay, so we have downsample here. Wait, how's this make sense? Downsample 0 should be keep the whole trajectory, right? Okay. Mini batch size is less than horizon. Okay. Fair point. We will just keep this 32 for now. It's a bunch of experiments. They're not doing well, though. And we owe M, so that means probably something is not getting freed correctly. Yeah, it's leaking GPU. So that's a problem. That's incredibly annoying. In fact. Well, we have it way too few time steps. So let's do this. Hello. Slow and steady. Is it the same graphs? Hey, you both sent me the same graphs. Yeah, it's very cool. It's very cool. Sweep not happy. Possibly we need to constrain this to play with this a little bit. Okay, let's figure out what we can. What can we constrain a little bit here? We can do like this. Two, 7, 4, 2, 6. Fixed 1. We constrain it a little bit. Hang on, something is wrong that this is only getting to like negative 14 or whatever. Okay, at least now it is sweeping stuff. I think the eval's too short though. This is usable data for Constellation at the very least. Yeah, that's actually sweeping stuff. Cool. Disney failed. Okay. Interesting. So we're not seeing. Oh, no, they are. They're very faint up top. And we have nowhere near as many points as we should have, I would think. Yeah, look at all these. We're supposed to have lots of these points. We're not seeing them for some reason. Am I being dumb with the shader? I don't think so. No? I only see 4 points. But there are a bunch of points right here. Cost. Agent steps. Perf. See, this is definitely... Is it getting filtered somehow? It shouldn't be. It definitely shouldn't be getting filtered. Let's see if we can figure out why this is getting screwed up the way it is. Okay. Tim's got 5 mil SPS on Sokoban. Sokoban's a very nice environment. Sounds good. I'm tired. I don't know. Sleep more. What? Let's see, it's plot 2, right? Where's our figure 2? Update closest. Points. Get hyper. Size. 20 points. Does that look right? Yeah. Y. One, two, three, 4, 5, 6, 7. Yeah, there are a lot of points here that should be... It should be fine. It's cost. I don't see these points though, so like 1.6 and 16. Where is this point? Plot GL. Plot. Do I have a non-GL plot? I've not looked at this code in a few months. It's weird though. I over nope. One, two, three, four, five. There are lots of these points. Glyphs. Ah, negative. Somehow this got transformed negative. Something's screwy here. Man, something's very screwy. I don't see the point that's supposed to be out here. This one here. 300. Is my 2px function wrong? I don't understand. What's wrong with my 2px function? Y is 400. I mean, this is definitely wrong. So how is this getting converted? Let's see if we can just like set a breakpoint. 2px. Oh, actually, hang on. Is this get hyper? The way to automate. Wait, I feel better if the elo game was not plateauing. No idea if it's not good enough for self-play algo. Yeah, so this is why you need like benchmark M's for this. Want to figure out if there's a way to automate easy. So I'm gonna plug in a scripted opponent. Yeah, so there are environments for which you can do that, right? But like chess, the scripted opponents are pretty complex and heavy. Okay, that looks like a nice point, right? Log x. X. How is x min? Oh, is this gonna end up being negative? Is this what's happening? Hang on. 2. xi, yi, zi. Okay. X. Yeah, it's negative. Well, this is totally screwy. It's not upside down, right? Like, agent would have way to figure out how to abuse it. Yeah. So, I mean, it's possible that there are games where this is not the case, but it's kind of difficult to think of any. It would have to be, like, basically the only thing I could think of is you'd have to have a, like, an imperfect information game where the information is a big advantage so that your scripted opponent can just cheat. That's basically the only way I can think of doing it. Pretty sure that this is supposed to be. There it is. Genuine bug in Constellation. It's embarrassing. Well, we're definitely now knowing that going to have some test data for this. That is a genuine Constellation bug. Now we have some data. See if I did it anywhere else. I think there you go. That's it. Yeah. Alright, well, we'll fiddle with this, but this is like a good start. So, I think with that, we can go back to figuring out how to actually get this thing to sweep correctly. Oops. Downsample is 10. Let's see what this is doing. See if within a few experiments this learns anything usable. And then we can also check Kyung's breakout sweeps for comparison. There's a lot we can do here. Okay. We are getting reasonable stuff now. Yeah, that's reasonable stuff. We are getting like runs that are sensible. We'll have to tune this. I think the next big issue is going to be the GPU mem, right? Let's see if this OOMs over time. I'm going to use the restroom. I'm going to let this do some experiments. And I'll see if this OOMs. Okay, yeah, that's definitely leaking memory. That's definitely leaking memory. It just goes up between runs, right? Yep. Okay, so it's just leaking all the mem. Let's see. That's the main thing that we fix. We gotta fix that and clean some stuff up. It says skill. That's funny. Samples collected. This is fair. Okay. Then we can just report SPS. It's fine. We'll just have a standard config for it. Okay, well this is okay. Again, total brain damage. Like, why the hell would you put that in the Python code? Oh, I'm dumb. It is in the, that is the C++ code. Okay. Me big dumb. Cool. Yes. Why did that look like Python to me? We'll see if that changes the mem usage. Okay. 2709. It's a bigger network. If it goes back down, we're good. STD bad Alec. on save checkpoint. Yeah, you can't do... This has to go here first. Look at the GPU utilization, by the way. Funny, it's like the utilization is a very bad metric. It's actually only at 100 watts. Of course, you give it a bigger network, it'll saturate a bit more. So 800K. 800K at 7 mil SPS. Pretty crazy. Yeah, so this is definitely broken because look at this. This is a 44K parameter network. And we're at 5800 MB. Yeah, so it's still leaking. Why is your GPU not maxed out when training? Like, why is it not at literally 100 and max wattage? This is the fastest RL implementation out there, and it's still nowhere near max what the hardware can do. It's very, very tough to optimize small networks. What in the... Fine, we'll do this. That's a mess. We'll try it though. What do you mean and not intermittently? It's sitting at 90, it's always being used. Like the utilization is very high, but like this number lies. This number does not mean your workload is effective. This just means that you're not literally letting the GPU sit idle doing nothing. It can still be doing stuff very inefficiently. Still leaking crap. Print tensor info. Fine, we'll do that real quick. Like we can just do here, let's do it this way. Do this, we'll do this. I really hate Torch. And I really hate Torch. It's just so annoying. One ref count. The policy is tiny. Okay, I mean, this could be some of it. Somehow better than Jack's. I Google engineers, I swear. So like Meta's the company that just does your bog standard big enterprise engineering and does it badly like you'd expect. Google's the company that does your big enterprise engineering, but then they think that they're very clever, so they come up with all sorts of new ways to make stuff shit. So Torch is basically shit in the standard way that you expect of big enterprise software. Like, you at least know what you're getting. Jax, you have to just twist your brain into this specific form of dementia that occupies Google engineers. I don't even know what the hell with that thing. This. I'm basically sick of dealing with Torch at this point, though. Huh? That's disgusting. Okay. This is fine for testing. If this at least works, then what we'll be able to do is we'll be able to like go through and see what of it is actually necessary. If this doesn't work, yeah, this dumb fuck thing, it's the exact same. We rebuilt, yeah, it's the exact same. The only thing that can be this big is the graphs. Yeah, and there's nothing else running. Yeah, this is just not fun. Not fun at all. What is this stuff he posts? Like, what is this, man? Graph pools aren't released. Okay. That could be it. Increase the number of M's and ends up stuttering and making the SPS. Well, you can't just infinitely increase num-M's, man. At some point, you're bandwidth bound. Like, go just for fun, go do the back of the envelope math for the number of flops that a network would take. Estimate 1 flop per parameter, right? And then the number of flops your GPU is technically capable of, and you'll see it's like we're not even close. All right, you're mostly memory bound. That said, you should be able to be training at millions of steps per second. No problem. It's just saving the mempool ID. That's fine. Let's try CUDA. Let's try the this thing now with CUDA graphs. We want to have 0 leaked memory. Damn it. I just have no interest in dealing with torches, crap wrappers for this. Device index, great. So now it's going to be GPU specific. We're not doing multi-GPU today though anyways. It is going in this version, but... Lovely. Whoops. Okay. Oops. That does not work. Caching allocator. Pool release to the end after all tensors are cleared. Pools can't be released while tensors captured still exist. Okay. Does that make sense? That's just moving it lower. Fine. See, this feels awful because I basically have fuck all I can do here. It's just undocumented PyTorch internals. Like, if I just had this in CUDA, it would literally just be like grep CUDA malloc, right? Pipe count. Grep CUDA free pipe count. Oops, the numbers don't match. And we'd be done. Lovely. I mean, this is just like checking shenanigans. I don't think you're gonna get this. Well, this might be a host error. Might be a host side error. Background. Did I rebuild? No, I didn't rebuild. Need this to not leak memory. Ooh. Hello, Tim. Tim has... Do you commit all the maps? Are these maps generated? What? Yeah, he committed all the map files. Easy and basic are... The easy and basic are generated. Mainly bound by data retransfer. Not anymore, Crit, because we have optimizations for that. It's a pretty flat profile, like everything can be optimized. Static problem sets. I can go look at the PR though for the the actual code file while I'm waiting. Okay. Patchy. Oh, there's a lot of mediums. 1 million static maps, great. torch, multi-discrete. Embedding is why it's going to be slow. I can make that faster for sure. Ending.c. This was probably annoying. No, that's fine. That's not bad. Ooh, I don't know. This probably loading of maps during env is not great. Yeah, that's gonna be not great. So I can look at, but I like the main thing is just like, is the env code good? In my view. $562 is not bad. Okay. First pass, I don't see anything totally stupid. I don't see anything totally stupid. Down. Questionable. Okay, that's questionable. I'll look at that. C step, cool. Create. This can be done way easier. Code does not look bad. I gotta give it a full review. Let's figure this out in the meantime. I mean, let's go back to doing this. Yeah. Did I just hang on? Yeah, right here. This check photograph's false is fine. So you lose 40% speed without coup de graphs. Or 30% speed. Better, but stuff is still leaked. We shouldn't have used 900 MB. Wait, 900 MB is leaked still, right? I want from blob shouldn't change. Okay, this is fine. I didn't realize that could fail. Be able to undo all this crap, of course, if need be. Need to not be leaking memory. Freeing. OBS is only 3.8 MB. Yeah. You know what? I want to try one other thing, which is I want to see basically if I just SSH in. I want to see if mem is still going up. Because it's possible that it's torch being weird. Here's the restroom again. Ooh, that's interesting, right? Okay, we're not actually... It might still be leaking if it's leaking only a little bit then. No, because it just went back down in Alex and then it went up. 1749. $13.21. Try this. Plot code. I want to get this thing out of my workflow. Pretty much at this point, I'm only using it to deal with awful undocumented torch bullshit. What the? Is it that dumb? Literally doesn't realize. Okay, whatever. Actually slowing you down? To be fair, at the moment it is Torch slowing me down, like Torch just being garbage, the internals of it. I do think that this would this would not help me for a lot of the stuff that I'm working on. It makes you feel like you're doing stuff faster, but you're really just making a fucking mess. Yeah, I don't know, I got sleep. I think I'm just sick of dealing with Torch. It's starting to get old. Yeah, it's definitely still leaking. Dude, that's so annoying. That's just so incredibly annoying. make sure that it's not that. I think that does the same thing. Yeah, no, that doesn't help. Is there anywhere else PyTorch should have Alex? I don't think so, right? Let me run this with train. Invalid device argument? Are you shitting me? What the heck is this? Literally the same bloody thing. Well, now it doesn't even freaking run. That's because I'm dumb. Hang on. Okay, so this goes down a little bit. This doesn't go down. This goes down, this goes down. Cool. You gotta fix that because, like, doing leak code qualifies you to ruin code bases on important problems. That's about it. It's just a very, very bad representation of actually what solving problems looks like. Okay, I mean, so this is here. What you need to do I mean, like, just pasting this into an LLM is completely stupid waste of time, right? I guess what I can do... Man, this is so crap, because it's like... No, the thing is, PyTorch allocates intermediates, and you literally don't know what the fuck it's doing. That's the problem. Stack trace. Isn't that torch like C stack trace? Did you just add that to the debug flags? That's good, but the full I can merge that, but the full debug equals 1. Like that also requires you to run with CPU and stuff. To run with your stuff. Oh, okay, that's nice. I will merge that. This is not a torch like crash though, Peru. Um, we're leaking memory, and there's basically no way for me to figure out how, because like Torch does whatever the hell Torch wants. Check this out. Let's see, what did you link me? Well, what's this do? Which mem is held by which tensors? With tensors you provide. Interesting. $517. I see. So, I mean, what would you recommend that I do with this, man? Because the issue I'm having here, right? Um, I know for sure with coup de graphs on, it's leaking memory because I can see it running out over time over experiments. I can't tell whether it is or not without coup de graphs on. It could just be leaking more slowly across experiments. It's hard to say. I can check my own allocations, right? But like, you essentially have no idea what the heck PyTorch does with intermediates. I looked into trying to make the full thing static. The conclusion I came to is if you want to make like Torch C++ API but static, you basically have to throw out Torch at that point because it's just not the way Torch is built. Plus the memory tracing. Use the out stuff. Yeah, so I tried that, Peru. It doesn't work with AutoGrad from what I saw. Like you literally just have to throw away Torch. Eval used 10x more mem than training did. That's odd. Some suggested embeddings. You can try them, Jess. Memory pressure could tease that apart. Well, but the thing is, I don't know what the hell is leaking, right? Because, like, I'm running sweeps now, Peru. So, like, from one training run to the next. and profiling. That's so, ugh, that's so rough. I mean, this is the thing that pisses me off is that this is just such a manufactured problem, right? Like if I just were writing my own library, it would literally be like um grep CUDA malloc pipe count and grep CUDA free pipe count and you're done. So like me having to spend my time fucking with PyTorch's shitty engineering is just not good. Like I want to minimize this because I think we're just gonna replace Torch at some point. Like this library has consumed enough hundreds of hours of my, remaining year of my 20s. Thank you very much. Enough hours. It's not going to be hundreds of hours this year. Screw that. I'm not spending hundreds of hours of the last year of my 20s dealing with Meta's absolute dog shit engineering. Like I'm going to be using this to solve RL. Um I guess I can do this, right? Oh, hang on. Is this going to help us? Yeah, this is going to help us. So here's the actual size of the leak, right? This is nice. Thank you for that. No, 5 will be Go Explore. We're not doing half updates. Eval run successfully. Let me think. Could I try that? I suppose I could try that. Cached workspaces. Great. Let's just make this thing super freaking slow. Let me try this real quick. Narrow down. Yeah, I can try that. I guess it could technically be eval. But we shouldn't be memory bound, right? Like, there should be very, very low memory usage. I mean, like VRAM bound. Obviously, the ops are mem bound. Wouldn't for larger models. That's nice. That's definitely nice. What am I doing? Same thing. Unless, hang on, is this slightly lower, actually? So I don't know if the gap is... Yeah, it is slightly lower. It's still leaking. Are we leaking stuff on both, then? I don't think I'm even allocating anything for the backward here. Eval's definitely the most of it. Not what I wanted to be doing today. Honestly, like, even the CUDA to C++ boundary with the launch functions, I think is a mistake. And honestly, the entire thing should just be like pufferlib.cu and we'd be done. That wouldn't even be hard, would it? Based on custom. Yeah, I mean, I think we could write a simple sweep for that though, right? Okay, after rollouts, this is 130. 130, right? Streams. Oh, well, actually, we can match this now. Like Torch aims to. The problem is, like, whoop did you do? You get to target your wide variety of devices and use them at, like, 20% efficiency or less with smaller nets. Hmm. The buffer states and the streams are the big two, I see. Yeah, the streams. Not fun. I think we fixed this. We see if we can fix graphs. Hopefully this doesn't take terribly long. And then we get initial constellation runs. Okay, it's during training, it allocates a bunch of crap. I'm not allocating a bunch of crap though, so I don't know how. I don't think I'm allocating a bunch of crap at the very least. Okay, so it's leaking 40. Buffer states is 78 MB. It's about right. Streams. And then total is what? 722. It's about 150. That's pretty close. For eval, could you replace most without pre-alloc? I tried that, Peru. You basically may as well delete Torch. Like, you completely break the model of Torch to the point that the code's unrecognizable. So I think I will do that, but it's like, I messed with it for a few hours. It was a disaster. Okay, so this is what I thought. So this is not actually leaking now. Apparently. Put coup de graphs on. This is just like awful. It doesn't look like Torch anymore. Yeah. What the fuck? so irritating, man. I'm getting to the point where I'm just really not enjoying my work anymore, and it's entirely because of Torch. Which is not good, because that always tanks productivity. All this shows is it's growing over time with coup de graphs. Through the GPU thermal sinks, yeah. Like, why does this shit even exist? I mean, couldn't you totally see just like Torch should have just been like um torch.cuh or whatever, right? That just has a bunch of kernels that are good that you can include. That would have been nice. Hmm. It's so annoying, like I can't even tell. I guess the one thing I can do, hang on. Yeah, my brain is just like off right now because it's just like I'm so bored with this shit, you know? The 4 MB. Yeah, so it's up to 200 or whatever with graphs. And the thing is, I still think it's leaking even without the stupid graphs on. I'm pretty sure it's still leaking. Only local rules. Yeah, I mean, we have drones. We've got like several like schooling type environments. You don't really need anything fancy whatsoever for that. There's like this unfinished version of Boyd's with Puffer. It's actually one of the better uses for Puffer because it's just tons of agents and pretty simple networks, and you can get some very cool results. I honestly think you can just drop our standard network in. You don't really need to innovate anything there. It's mostly just the environment and having a reasonable reward, and you're good. I'm actually just considering having the hyperparam sweep just run shit in a sub process. That's so bad though. Like, I worked so hard to not have to do that. No, we can't do that. God, I just hate this. This is like everything about this is just awful. It just puts you into this box where there's like fuck all you can do other than bang your head against it till it bleeds. This is what happens when you have like shitty enterprise frameworks that you're stuck with. Well, we need to at least get the train function running, right? I don't know why this suddenly magically broke. Yeah, invalid device argument with no trace. I tried this with a C plus with the C++ stack trace. It just does not work. Just do this. Yeah, look. It's just like no trace. I don't even understand how it's possible that doesn't give you a trace. Right? Like how? No stack. Lovely. Okay, here's our standalone with presumably coup de grace. No, coup de grace is off. Yeah, streams needs free. Okay, so yeah, nothing is getting freed until you call. Where's the CUDA caching allocator? I see what we need to do. Maddening, but I see what we need to do. So right here, Jesus. $130 MB. Rollouts matches. What is it? Difference? 250. We run 2 experiments. I'm just gonna put train twice. We're gonna see if what happens. I mean, this is just so incredibly disappointing that this is like this. It's a 20 MB leak, it looks like, right? I mean, you just can't tell with this, though, at all. The policy weights aren't 20 megs. Hmm. This is not a thing, is it? No, apparently it is a thing. I don't know if it's the same thing as before. Okay, hang on. There's 877 goes down to 835. Yeah, you see that? So that actually, that frees quite a bit. Yes, okay, good. There's no leaks. Yeah, there are actually no leaks here. God damn, that is annoying. Holy hell. That is so obnoxious. You literally can't even tell if you have leaks. Great feature. Now, unfortunately, with the memory caching thing, hang on. Now we have to do this without the freaking caching allocator. Or with the without that flag, with the allocator. Oh, actually, look, it matches even here with the workspace clears. So this is very good. So as long as we clear the cuBLAS workspace, uses a lot of memory with CUDA graphs. Okay, so we have 15 mem close end. This says no leaks. Yeah, this says no leaks. Okay. Nope, not this one. Okay. It looks like we can just free the workspace. Jess. I'm gonna just let this run a bit while I go get myself a cup of tea, maybe grab myself a snack. I think we have it fine now. I don't know for sure, but I think we have it fine. I'll be right back, guys. Okay. Looks stable to me. That's nice. Man, that was irritating. That was irritating. Do this. Just the fact that it was such a pain to figure out if stuff is even leaking at all. Images. Just do this myself. Yeah, this is not gonna error ever. Any tip on how to prevent overlapping agents? What do you mean overlapping agents? Like how to prevent them from physically colliding with each other? It depends entirely on the environment, you know? Sometimes it's as easy as just partitioning stuff into a grid and only letting one thing be per grid cell. If you have continuous space, then you partition stuff into chunks, and you only check the current chunk and adjacent chunks. As long as things don't group up a ton, like you can do this stuff pretty efficiently. Continuous space, then you're going to want to chunk it. I mean, it depends how many agents, right? If you have a couple hundred agents, you can actually get away with just doing it in a loop naively. Um, if you have thousands, then you'd use chunks. Chunks? No. So by chunks, it's what you do, like instead of checking all possible pairs, right? You split the space up into chunks, and then you only check collisions within those chunks. That's how you do that quickly. All the collisions, I have to run multiple iterations to resolve. What type of collisions are you doing, right? Like, do you have complex collision geometry or is it just spheres? Because if it's spheres, it's really easy. If you can do it with bounding spheres, it's really easy. What env are you building? Yeah. Setting a penalty? Not really. Not really efficient to do penalty. I mean, you end up doing both is the thing. Like, they get penalized for colliding to some extent, and then you disallow the collisions in the code. Alright. Alright, I needed something funny after dealing with this crap. That was. Thank you, Yasin. That very much delivered. Oh. After displacing each pair, see, you don't need to like displace them. You just disallow them from colliding. Like when it moves, if it's gonna collide, don't do that. It's that easy. Yeah, average. That's pretty funny. That is pretty funny. All right, go away, Claude. Let's get a few experiments out of this. Oops, actually, hang on. We can do this. That's smart, yeah. I mean, very small changes like this will make a massive difference in if stuff is fast or not. Then, like, boom, you no longer need that entire chunk of code and all that wasted compute, right? It just worked. Oh, these don't have means on them anymore, do they? We're just using the defaults. Set it to 7. We set it to 7. 5e6 to like 7 maybe. Nah. Yeah, we can do this. Cost is 10. Okay, cool. Let's see if this does anything. And this does not optimize. We'll give it a few more of these experiments. And then we'll try it with breakout after. Okay. Well, we can run this and see. 30-second max. It's not bad. Let's see if we get at least a few reasonable experiments out of this. We can play with constellation and see what we do from there. It does not seem to be finding good good configs, which is kind of weird. It is a very large search space, I suppose. No, but we should definitely have this working. Well, I mean, this is the full search space, so presumably we can prune chunks of it, but that's one of the objectives of Constellation. Oh, there you go. I mean, that was some signal at the very least. So no, presumably there's some numerical instability with bfloat, there's some numerical instability from kernels. We're not going to get amazing sweeps out of everything just yet. That is real learning though, right there. From like whatever params it just chose. We did get kind of lucky, I would say, then with the current breakout setup that we were able to maintain perf and keep it stable. But now we can do stuff like sweep bfloat versus float 32. And we can do lots of stuff. And we can do that on Wandby and we can do it on Constellation both. I think what I should do is let's let this run a few more so that we have them for Constellation to play with. And then what I can do is I can just see if I have the Wandby integration set up. And then I can hopefully have this thing stable enough for contributors to play around with. And I can start running experiments myself as well, which is nice. I mean, it is normal that it takes a couple dozen runs sometimes to even pick any signal up. So that plus instability plus all the other stuff, yeah. I think that's fine. Let's just kill off some old arcs. We don't need any of this. Hidden size, num layers, expansion factor. Size, num layers. Yep, that's the same. We're good. Yeah, we're perfectly set. Yeah, oh, there it was. That was a good run, wasn't it? Yeah. Cool. So that'll give us some data. Doing 3-second runs for some reason. Had 18 million steps per second with tiny little networks. They actually learned a little bit with a 40k param network. Is funny. 10k param network. Okay, maybe it should not be able to run 10,000 parameter networks. All right, maybe we're gonna cap this at 64 smallest. And we'll do that for now. Eh, 32 maybe. We'll let it do 32s. Shoot, that's actually did pretty well with huh. Alright, maybe it does actually work. Well, we'll be able to compare nicely either way. Okay. Yep, there's the dot there. So we only have a few good runs. And should be a lot more bad runs, though. Which I'm not seeing. Interesting. Yeah, not that many points there. That's pretty cool. There we are. That's a few more points, right? I think that's nice. So, I mean, there's not really a need for us to run this entire thing. I do think we probably want to have this thing set up with wand B. And if this works, then we pretty much have sweeps integration. I do kind of like the idea of also saving the wand B runs to local. Failed? Why failed? No, okay, log cost. Log cost. Sudoku would be? Actually, ask Weston. I'm pretty sure Weston did Sudoku. The Discord. It's Tanky Chopper in the Discord, actually, I think his name is. Multi-GPU sweeps. Multi-GPU sweeps are actually quite easy to do. Substantially easier than multi-GPU, like single runs are. So that will be done before multi-GPU single runs are. Okay, this works. This is nice. So let's just status make a nice commit. Okay. Well, we now have some basic sweeps testing. Yeah, you can actually right click all the points, which is kind of cool. Much left to be done. Much left to be done. It's 4 p.m. I could try the multi-GPU sweep stuff. Over Wandby. Go ahead and try to load up like 4,000 experiments in Wandby, see if it works. So this thing, I will be able to load up sweep data across all the environments in aggregate, like 10,000 plus runs. And like we will have all sorts of stats instantly. It's just way better for large scale aggregate monitoring. You pretty much have the same interface where you have custom plots, you've got extras, you've got hyperparam stability regions. This is not filled in yet, but this will be a t-SNE. I don't know, Jess, if you ever saw the original version of Constellation with with a bunch of data loaded in. It looks really freaking sweet when you have a bunch of data loaded in. And it's obviously still needs some polish. It's not fully done. Constellation? No, not another client. This is part of Puffer 4.0. It's our high-perf visualizer that's written in C. So we just have our own standalone like visualizer for data. It's like our version of like our Wandabe or whatever, though it's for something a little different. Hey Tim. The data down here is just dummy, but then up here, this is like a few runs of 4.0 data actually loaded into Constellation. So this is like this, what is this, 7 seconds or whatever to solve loaded in. Tim, I'm mostly just exhausted from having dealt with PyTorch so much. Like, I really don't want to have PyTorch be a thing. We have to keep it for now, but I don't really want to spend much more time fighting Torch. I'm trying to think next steps here. Hyperparams, yeah. So you can look. This is cost versus score. So I can do clip coefficient versus score. I can do mini batch size versus score. I can do whatever I want versus score. And like you can do this in Wandabe as well, but it'll lag. And if you try to put 5,000 points, it'll say, haha, are you kidding me? What do you think we are, a NASA supercomputer? So here you just have whatever points you want. You can just like plot stuff instantly, and this will handle thousands of points. And you can see here there's an all option. When you have multiple M's, you can just click what env you want from the dropdown, or you can click all and have all the M's at once. So it's just like, hey, what if data viz weren't super slow and we could do aggregate viz over a ton of M's at the same time? And then the other reason I wrote this is because I wanted to do benchmarks, full sweeps for every env in Puffer, and then I wanted to just put it on the website. So like this will live on the website with all of the data from all the sweeps loaded in for 4.0. So you will have the highest performance, biggest set of experiments ever run in RL, and it'll just like have all the aggregate data in your browser. Stable hyper range. Yeah, that's down here. It's not very interesting with just one env and a few data points, but it's here. Okay. Um, there are a few things I'd like to do at the moment, I think. Yeah, there are a few things I would like to do. Let's just real quick, let's see if we can figure out some stability. Yeah, Jess, it would extend, like, it would be at least another couple months of dev to fully rip out PyTorch. I can't delay Puffer that long. It's already been way too long. Okay, so in order to get this thing to train, this thing needs to not have hurdles and BF16. If I do this, genuinely less stable with BF16. Interesting. I I do wonder if these go hand in hand though, because like one of the big things about having our custom kernels is that we don't end up casting to BF16 so many times for intermediaries. Get this SPS. Oh, this is nothing, Tim. This is nothing. You want SPS? Here, I'll show you. Puffer, train, puffer, breakout. Don't blink. There you go. 7 seconds. Breakout solved. Yeah, 14 mil. Usually about 14. I honestly think we can probably even go a fair bit faster without torch, but we're stuck with torch for now. It's been a lot of work. It is, unfortunately, it's genuinely the case here. Oh, wait, how fast is this? 12 mil, 13 mil. Yeah, okay, so I mean, that's the speed that you expect. But then why are our kernels unstable? Let's just see if it's like a silly little thing here. If I just like lower, probably 6. No, breakout's usually the simplest env that's still meaningful. Let me actually... Before I bug him, let me double check one thing. Is it just doing multi-discrete wrong? What is another multi-discrete env? Oh, it's probably just this being dumb. What's the hardest env? Maze? I mean, neural MMO is really hard. I guess the driving, like the larger scale configs of driving are pretty tough. And then like mazes you can make arbitrarily hard, but it's only meaningful for certain types of things, right? Like mazes are an environment that you pull out for a specific type of benchmark. Let's not embarrass myself bothering Jonah when maybe I'm just dumb here. Okay, so this starts training instantly, right? What happens if I have custom kernels on? Doesn't train. Okay, so maybe just BF16 without kernels is bad. Let me test one other thing. Let's not be, like, stupid here. Let's do kernels equals false. Oh yeah, it'll be very good. Sokoban will be nice. It'll be like in the same sort of category as the Mazen. We'll use it for mainly like the algorithms research. Which is nice for Puffer 5 actually. Ah, okay. BF16 not stable without custom kernels. Custom kernels not stable for multi-discrete, I think. We'll just have this do quick check in case it's dumb and easy. And if not, we'll sort it from there. And I'm going to start looking for it at the same time. So we get num actions. Yeah, get num actions. I wouldn't be surprised at some striding bullshit. There's no way this can possibly be correct, is there? Or where do we get num actions from? Actually, maybe it is? Hmm. Okay, well this takes a bunch of strides. I'm a little suspicious of this. I'm a bit suspicious of this. We are passing stream, right? Yeah, we are passing stream. Nice, this is forward only. That makes it a little easier. Pro stride may be sum of act sizes for fused output. I think that's like an easy thing to check. So for all logits together, it'll... Okay, I mean, this is easy for us to check, right? I would believe that. Did I not merge this fix? I thought I had merged this fix. Isn't this actually what Jonah fixed? False. Let's try false. Python set I build in place force. Like so. And then if this works, this should make Puffer work on a lot more M's. Aha! Ho 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 ho. Yes, this works. Does it work with BF16? It does work with BF16. Good job. Okay, that's super sweet. So all we had to do is go check if I've been a donut and if I have a PR open for this. Credit assignment. This is for checkers. Good. Sweep and env in 10 minutes. You literally can do that for Pong. How's your SP3 going 1,000 steps in? Yeah. Yes. That I think it will not screw up. That's like changing 2 loops, right? I should check this one though. This one is like bad to mess up. And then we have our perf benchmarks. Actually, then if this is like BF16 is numerically stable, that's really freaking good for us, isn't it? Oh, I remember what Jonah fixed. Okay. Yeah, that's not too bad of a difference, because it's just a sum. And the entropy as well. Yeah, it's not bad. Might be a little weird for backward, I don't know. I don't think it should be. No, I think this is a like it's straightforward enough fix that this thing will just do it. It's essentially adding a for loop here. It's very easy to screw up is the thing. It is very easy to screw up here and here. And then the launch functions and the module bindings and the torch bindings and all that crap. This also here, this being commented is sketch. I think this being commented is very sketch. I'm gonna have to double check that. We'll say this is what we'll work on today. That way we can run, we should be able to start running some basic sweeps. And we should actually have it be so that we save logs also locally. We'll just do that. That's easy enough. Ah, stupid Claude. Fine. Freaking Claude tax. Now this ought to last for a while though, because I'm not using it anywhere near as much. There is still some refactor that will have to be... It's like AI having to clean up AI slop, so whatever. Proceed. Thing. Let me go look at this in the meantime. As I do think that this is a little screwy. Yeah, we do not update. We do not update the ratio, do we? MB ratio. Yeah, this does not get updated. Okay. We will play with that then. Well, we found one thing that I definitely messed with in the implementation that we should probably fix. I forget if it messed up graphing. It shouldn't. I mean, I'll be able to mess with that, though. That could very well be the thing that's screwing up our train impl. Accumulated values. Okay, let's actually see what this is. Pull out maze. What do you mean? Is it complexity type quantifiable? So Jess, it's a pure exploration task. So there are algorithmic improvements that you would expect to make the method better on mazes, and then there are algorithmic improvements you would not expect to make better on mazes. Mazes are very good because if you know what you're studying, they transfer incredibly well to a wide class of problems. But like, so the basic understanding of RL, right, is we have a bunch of environments and some are easy and some are hard. And if we make our algorithms better on all the environments, then our algorithms are probably better everywhere. So we advance the field, right? If we want to be a bit more precise, we can kind of use different environments to study different subproblems of learning. And mazes cover a couple of those different subproblems depending on how you set them up. So like there are specific types of algorithmic improvements where mazes are a very good benchmark because they isolate the one thing you're studying. And then there are certain classes of algorithmic improvements where they don't. For Puffer 5, for instance, we expect that we're going to be heavily using mazes. And then if Tim finishes Sokoban, that'll also be a great end for it. We actually don't expect Puffer 5 to make a dramatic difference on, say, Breakout, for instance. Though it might, but we don't expect it to. Does that make sense? Exploration. Yes, except that it's you can't just say exploration because that itself is poorly defined. There are definitely measures, but like they're kind of difficult to explain. Let me sort of try to give you a little bit of the basics here. So mazes are cool because you can learn an agent that learns the exploration strategy for mazes itself. So you can have it train on a bunch of mazes and try to solve a new unsolved maze more quickly by having learned a good exploration strategy. You can use mazes as sparse reward problems where you have a really big maze and you just see how long it takes your algorithm to get to the end. And those two things are very different. So you kind of have two separate ways you can use mazes. And then improving on either of those subtasks is going to correlate to improving performance on other tasks, at least somewhat predictably. How does maze solve mazes? Isn't it just BFS? Yes, so you can absolutely just solve the maze in like 4 lines of code, or what is it, 10 lines of code with BFS. That's not the point, right? Because the thing is, the RL can solve other problems that you can't solve with BFS, and that doesn't make it a bad benchmark. It's kind of funny that this thing can do, I think that this is correct, that it can do kernel logic, but it can't do like, because this is actually relatively hard. This is okay. Launchers it can totally do. Launchers I'm not worried about. That's actually what it's for. I'm more worried about the logic. Uh eh? Hang on, that's PufferLib is. What? Loss output. Oh, loss output is a float. That's good. That was also probably screwing it up then. This is the chunk that's mostly like, ain't nobody want to edit that. It will be interesting though if we actually even end up needing the float path. It's a bit annoying because like if you ever have numerical instability, you kind of want to have the float path. It adds so much jank code though. But I have not written any articles or anything lately. Probably need to do that. I'm tired. That I can merge instantly. Done with that. Modules. Cool. Well, we'll see whether I get burned for this or not. To be clear, I don't mean for updating the module logic like this. The module logic should absolutely be done this way, because like this is just a bunch of boilerplate garbage from Torch. If I were to write my own library, none of this would even exist. It's mostly the kernel that I could get burned on. I did check those ones way more carefully. But that one I will admit I could totally have screwed up. Only deal with one stupid Torch thing for today, and today it was the memory, the OMMing. Size is fine. The caller just needs to pass act sizes, it's easy enough. And that's static, so it should work with CUDA graphs, which is fine. Not exposed. We're fine. Target in place, force. And then if this works, I should now be able to train with bfloat and custom kernels. Which are the defaults. And it works. Nice. Slime volley. That actually probably fixes a bunch of stuff for us. Like, that's probably why a lot of our stuff was jank. It wasn't numerical bugs. We should still probably run like the optimized, the tuned versions with custom kernels and without. But yeah, this is good. This is exactly what we want. Perfect. Let's commit this. Okay. How can RL learn which way to explore if they're randomly generated? So the idea, right, Calamaria, is like you can do stuff like always follow the left wall. You can do stuff like remembering which branches you've taken and like exploring new ones. Random exploration is very, very, very bad at mazes, like exponentially bad. So you can't really do better than quadratic on mazes. You do kind of just have to explore the whole thing, but that's a hell of a lot better than exponential. So you can still learn. There's a lot that you can still learn on mazes, and the goal would be that you learn something that approaches not BFS, because BFS is not an algorithm that you can actually run in practice, but like DFS. It should be comparable to DFS if you optimize well. And if the goal is always in the same spot, then it should be comparable more, not exactly to A star, but kind of. Okay. Well, this is super nice. I think we just like go run some environments, right? Because a lot of the stuff that didn't work before should now just work. Let me use the restroom real quick, and then we'll see what I can do with this. I'm gonna grab some tea as well. All right. Why is BFS not feasible? Well, in mazes it is. The point though is like the point isn't that yay now we can solve mazes. That's so important, right? Just because it happens to be that in maze, like here, for instance, I could swap the mazes to be in continuous space, and the RL would work just the same, but your BFS wouldn't. Now, yeah, you could discretize it, right? But the point is I can just go get harder problems, and the RL works, and mazes don't. And it used to be the case that maybe the RL worked in theory, but it actually didn't. Now the RL actually works. So, there you have it. Let's see if we can get some basic stuff done on, it's like our basic configs. You don't need to have BF16 off. Okay, let's get rid of this off. This is silly. Let's go check Pong. Algorithmic improvements beyond exploration. Well, there are a few different topics within exploration just that matter at the moment. One is based on state sets, another is based on like novelty and observations. We learned from our well, what it means, Calamaria, is the algorithmic improvements that we make here let us take the exact same training code and chuck it on harder problems, and it just works. Like, I've done very little work on these individual environments trying to get RL to solve all these individual tasks. And like as we do more on the core of PufferLib, we need less and less work for every new problem we want to solve. Okay, so we have different params here, right? This is supposed to be... Yeah, see, we have very different parameters here. So let's just take these. Let's put them into here real quick. Go like this. And then we'll do... This is supposed to be 8. Right, and then this is supposed to be total agents. Whoops, toad. And then we have all these parameters. We can probably just do this. This work now? does not work. Okay, this is not needed. Current. Nope. Update epochs. Kernels, false. BF16 equals false. Don't think this does it either. Yeah, that's still not good and stable. Just to see if these are good in any event. No, that does not seem particularly useful now, does it? Okay, so it's not that. That's super weird. Okay. What happens? I got a question, right? Here's the question. What happens if I do this? What happens is we okay. What if I do this one now? Let's go down the line. Not amazing. Really not amazing. Well, now I have a question is if I do this, does this make it worse? Nope. In fact, it looks more stable to me. Cool. That seems fine. So it's not the difference in those custom kernels then. Unless I have it commented here. Oh, you know what? No, we have it right here. There's the ratio. This is not done in the kernel. That is not done in the kernel. Interesting. That's fine. It's at least a decent starting point, I would think, right? 5 mil to 50 mil. Oh, you know the one that I want to check is this one here. What was this, like 500K? This 500K SPS config? I wonder if this one works. This was, I have to go back a whole bunch of commits to see where this was from. But I want to see if this works. Hidden size. 512. Okay. Let's see what happens if I do this. Frame skip 4. Okay, so that's an issue because that's really fast and we don't get any logs. Now mini batches is 8. I think that makes sense. Do we have update epochs in here? No. I can't understand how Puffer gets better at solving hard problems. I understand about PPO mini. What do you mean you understand about PPO mini batches? You don't understand how we take the baseline most successful algorithm in the field, which has not been extensively evaluated on a ton of different environments because everybody's implementations are very slow. We crowdsource, develop a ton of environments. We test our implementation and fix little things here and there on that. We make it faster and faster so we can have more and more stable and robust tests. And then we do a little bit of research and we find a few changes to PPO that actually work broadly across all the environments. Like, you don't understand how that loop works? That seems like a pretty solid recipe, no? Why do we not get logs back from this thing? Are we just not printing the dashboard? We are. Logs are here. Oh, I know what it is. There we go. This is why everything's been screwy. So it doesn't learn. At least we fixed the log bug though. I tried to implement it with mini batches, proper ops actions. With buffer, I'll just break out. It's not easy to get results. No, it isn't. It's not easy at all. This is why it's like, oh, it's so easy, right? It's just like a couple hundred lines of code. Here, I'm gonna go do that right now. Like a number of people have tried to do that and failed. That's expected. Dude, this is literally, if you read my guide tells you explicitly not to do that because you're gonna not like it's not gonna work and you're gonna feel really stupid. Dude, I could not just sit down and implement PPO and have it work correctly within a few hours. It's like RL is not that way. That doesn't work that way, dude. You should not feel bad about that. So let's do 5 mil instead of this. It's like I did warn you, you know? Alright, so this was probably some super brittle thing, but hey, at the very least, what we get to do with this. I wonder if it was 128 actually. Probably was. 128, 12 mil, 8. I'm relieved. Did you read my guide? Because my guide did warn you of this. Like, I wrote it for a reason, man. I don't even know what PPO is. If you want to learn, we have all the resources around for you. Alright, well, this is stupid, but this is a perfect solve, so I guess we'll just say, yay, we have Pong. I read one guy of you. Not their long one. One guide, I imagine, yeah. I only have 2 guides, right? My general one and then my long RL one. It has all of my best advice in one place. There's literally not a more efficient way to learn RL out there. If you follow that guide, you will learn RL. It's that straightforward. It really just is that way, you know? Okay, that insta solves. That solves. Cart pull. Not solving cart pull. Not ideal. Back. Okay, well, we can fix that real quick. Hang on. David Silvers, I haven't seen him. Not the rigorous math. My guides are not very math intensive. Have you seen, like, here, look. Alright, I'll show you what I have. This is how I suggest people learn RL. This guide. It's not a short read, but it's not really a super long read either. It's also interactive. Like, you don't just read this and you learn RL. You have to do the stuff that the guide says. So, like, build a simple environment and train an agent. Here, this is a link. Now, read this. Now, do that. Write your own env, ask here if stuck. Read this blog. Now, read this section. Now, read and train this environment. Okay, cool. Now you've done this. Now, make something like this about this complexity. Read this code, add this to your own code. Here is when I have you read the a chunk of the PPO stuff. Like, you read a couple bullets, then you read the PPO paper, or at least most of it. And this is literally right here. Hey, Liberty, this would have prevented you from doing that. Understand why I didn't have you implement the algorithm. Literally right there in bold. So it has all the advice. This is a list of papers. There are only like 10 of them. You don't have to read all of them right up front. You can read those over time. A bunch of advice, some stuff on apps, some stuff on algorithms. Boom. It has 4 cards, first of all. So, good luck. FP8 training, Jesus. Damn, yep. Yeah, that's an I told you so-er, unfortunately. What the heck is wrong with this? Okay, it's a little silly, but like, if you just train for 50 mil steps. Was it unstable? It is unstable. Ooh. Can I just like, yes? No. Can I not just guess? That's funny. This ought to be a real easy environment. What happened to this? Failing to solve cart pole is definitely an interesting one. Agents 1. Ah, well, that'll do it. What happened here? When did this get introduced? Did somebody PR a fix to cartpole that was not a fix? Let me see if I did this. Did I goober this? No, I didn't. How'd this happen? Oh, wait, it's still here in 3.0? Ah, I see. Okay. Force mag, tau. It's actually, there's a lot of stuff in here we're not, yeah, what the heck? D... Oh wait, that's just DT. Full mass, cart mass, full length, gravity force mag. T. Hmm. Dash weird. Huh. That's a weird one. It's definitely a weird one. Oops. Yeah, just completely unstable, right? Okay, so what is wrong with cart pole? Not a question I thought I'd have to ask. Oh yeah, I guess we can do, 2 actions and 4 obs. Let's just make sure that's correct. 4 obs. 2. Okay, so that is correct. Fine. Did I copy params over wrong? No? That's weird then. I don't know why that happens. I did get a PR though for the dynamics being jank, so I'm gonna leave that alone for now. Build. Why did it die at the end? Oh, you know what? Hang on, I'm dumb. I renamed a bunch of parameters like a goober. Cool. That runs. Did I do any of these? These ones should have been the same though. Next 4 trash pickup. We can just do trash pickup real quick. Trash. We know R where seg faults for whatever dumb reason. Env has num agents. Cool, no other params. Yeah, this is the wrong. Hang on, this is the wrong thing. Not great. Okay, so we definitely then still have some screwy stuff going on. Triple triad. Real fast though. Definitely more stable than we had before. Let's do this. Oh, interesting. Hang on. Is there some total agents bug? Because that, if I just remove this, no, it's just screwy. But I remember this having a different config, like. Really? How does this not have a lower gamma on it or something at least? That doesn't make sense. If I literally gamma is 0.95 or whatever, does this not just work? Yeah. Okay, well I don't know why the heck that wasn't there. But yeah, this doesn't need to... I can literally just do this, and this will work. There. Cool. Let's try it. Blastar. Blastar is sketchy. We did Pong and Breakout. Freeway 2048. Pac-Man. Let me go try Pac-Man. Oh, this is better than before immediately. Because I remember it was stuck at like 109 or whatever. So that's fine, that runs. Let's see how fast Tetris is. Retraining 6 mil SPS, 8 mil SPS. Why is it getting faster and faster? Isn't that sketchy? Oh, it's because it's not resetting as frequently. That's funny. Heh. The reset must be slow. That's way faster than we used to be able to train, so that's sweet. Num layers 1 should not be 1. This should be 4. So this is not going to be the same, well, let me see. Let's actually go check, it's in 3.0, right? Please. 256 hidden. Oh, that's 61 lines deleted. Holy. Let's just do num layers 4. Yeah, so this should be the fair comparison. We can get rid of these params. These are no longer a thing. These are no longer a thing. We just get rid of this. Okay, 65 lines. Look at that. Come on. Train me some policy. Is it really better with one layer? That'd be kind of sketch. This is not learning, right? That is still a 849K environment running 5+ mil SPS, which is kind of cool. But it's just not catching on to the reward one bit. That's going to need a resweep. It's kind of weird that it works with one layer. Yeah, it catches on with one layer. That's funny. Encouraging. Enduro, we should just make sure works. I mean, this is learning, right? Logs are just super infrequent. Yeah, this is learning. We're good. Enduro takes forever. Puffer convert. Convert's a fun env. Agents. Presumably this is fast. Maybe not. I don't remember if they can see each other. Oh yeah, apparently they can see each other, so that makes env slow. Episode length decreasing is good. Works as intended. We have Snake. Snake has been sketchy. Snake has been sketchy lately. Let's see if our magic changes fix everything or not. So what do we have? Env num 8. So we have Vec total agents. 4096. We get rid of num m's. We update the parameter names, and we see if suddenly snake is no longer weird. It's still weird and unstable, man. Yeah, I don't know. This num mini batches thing is kind of weird. Hang on, let me look at this. Oh no, that's normal for 4096 agents, right? Yeah, that's normal. I don't know why this param is literally 0. That's like super odd. One last thing. What happens if I do this? Or actually, two last things real quick. So like, let's try something. First step is we do this. Oop. I'm trying to remember if this was able to get to 100 plus before. I think this does get to 100 plus in 3.0. It does look like it's not the environment being super jank though. It's just the hypers. Yeah. Maybe Puffer 3 just found some wacky hypers. I don't know. This is not bad perf. I don't even remember if we have the snake encoder or not in Puffer. We do. I don't think it's the good snake encoder though. It's like the dumb snake encoder. This is fine. Yeah, so it's, I mean, Puffer's pretty stable. It's literally just the some of the individual configs. Go. Well, Go needs a custom net. Hang on. Drone is continuous. Custom net, custom net. Everything else is custom net, hasn't been ported. I do want to see real quick with neural MMO. Agents or total agents. Total agents 4096. And then we have mini batch size, go away with this. Batch size can go away. Oh wait, is that batch size is kind of suspicious, isn't it? Because it's 4096. Yeah, that's a little suspicious. I'm gonna try this. start plus length exceeds what happened? In place, force dummy. $700-ish K. Not bad. I was hoping it would be faster. Oh wait, that's a quite large network. That's a quite large network, 4.4 mil. Okay, that makes sense then. That can get swept over though. It'd be interesting if now we have something that just like, that learns way better quickly or something. I mean, that episode length is good. Combat level, it's got a few agents that are getting some combat experience. Nobody's figured out how to get items yet. The profession level is 0. And this would take, what, 2 days to train 100 bill? With the current params? That's not bad. I think we can do better. But it's not a bad start. You do actually get some learning signal immediately in the sense that the episode length is increasing, right? Oh, you know one thing I want to try now? There is actually one thing I want to try. What happens if we throw defaults at this? You know? What just happens if I comment everything? Are we magically smart? What's our default at? And gamma 99. Like, are we just magically smart if we do this? Actually, we'll give it the full complement of 8192Ms. Okay, it shouldn't be slower. That's not a thing that should happen. Oh, look at that ep length. Holy crap, look at that. We are actually learning immediately. You see that? Though what are we learning to do? Like, the combat level is 0. So we're mostly just learning to walk around and not die. What smart thing did you do? What smart thing? I don't know if I've done any smart things today. I do wonder if there is, I wonder if there's something to it, like, just not wanting to risk anything at all. Because it's not, like, it's not getting any combat. There's probably just some dynamic here that I'm, like, not understanding. Look at the tiny little network. Boom. Episode length instantly going up. Oh! Oh, look, guys. Look at that. It's learning to fight a little bit in 1 minute with the tiny little network. Oh, we're gonna have fun sweeping this environment. Pain avoidance. It depends what you mean. I do think that the cool thing, though, is we can probably run a much shorter sweep on this. 3 minutes is what? Yeah, we can probably run a much shorter sweep on this and get something now. Which is pretty cool. Wait, was that? I think that was like little .01s in the prof level. Or did I see that wrong? I saw a couple in sales. Mincom prof. Yeah, it is. Ooh. Oh, we're also at 900k SPS. That's pretty exciting. So I think basically we can get excited that we probably are going to be able to sweep this and have it at least learn something in like 500 mil. We'll see. Enough of this. I do want to figure out what's going on with this. I should be able to do, like, does it need 8 buffers or something? Is it too big? 16384, maybe. No. No, I'm just messing with some M's, just like playing with Puffer, seeing it to what's stable. Horizon is 64. Wonder if it is the end of bandwidth at this point then. It shouldn't be. 62% time and forward. 2 buffers. Try 2 buffers. Even slower. Uh-oh. Wait, how do we have 774K? It's just the conv encoder? Yeah, it's just the conv encoder. Well, this is the fastest config I see. And bandwidth, all that crap. I just want to try one last ridiculous thing just to see. Bastion ends. We should probably play with those now that we have like the our efficient backends. Oh yeah, you know the one other thing? I think that this disabled QDNN optimizations. Did this disable? Set bench, no, benchmark is true. So this is fine. Didn't disable our optimizations. It's annoying. It's about what we had before then. Well, that's all the nets we have encoders for. I think it's gonna be. Let's make some commits real quick, and then I know what I gotta set up. Start.ini. Extra com dev seemingly better. So Jess, the thing is that in Puffer 4, you can stack the recurrent cell deeper. So there's going to be like, there are multiple options you have available. It's not just like you have to stack encoder. Okay, let's make sure that this is stable, and then we'll let this just run while I have dinner. Oh yeah, Wanbi is actually now, it's pretty swift, so it's well, it's good with this interval. Do I want to make it save? Maybe I just want to do this real quick. I'll just try this. Nope. Are we broken? This thing is... Come on. Yay, it runs. CNN for images. CNN is for 2D spatial inputs. So chess is a 2D board. The point of CNN is to tell the network that this thing close to each other, like this thing that's near this other thing, probably matters than this more than this thing that's over there. Which can be good or bad. Okay, this seems to run. I think I'm just going to leave this here, detached, and we're gonna see what happens. And we get to start on the loop where we run lots of experiments a little bit, but we also have to fix up lots and lots of stuff left in Puffer. But we have the end-to-end, and I would say that this counts as a pre-alpha, so it's pretty much pre-alpha ready. You can go download it, you can play with it. The docs are not updated yet, so you have to do setup.py build env name in order to train a specific env. But that's pretty much it. I'm going to go get some food. I may or may not do an evening stream. We shall see. To be determined. If you'd like to support my work for absolutely free, pufferfish like stars. Fun fact. Feed this one a star on GitHub to help me out. You can join Discord to get involved with dev. And you can follow me on X for more RL content. I will be back probably a little bit tomorrow, definitely Thursday, maybe even later tonight. Thank you all. Have a nice evening.